Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani from Department of Computer Science, Aryabhatta College, University of Delhi. So as you are aware of that, we are presently going through the series of our operating system concepts, and today's lecture is about the term threads. So we'll try to understand what is threads, what is the difference between threads and process, and then what are the advantages of threads, and where the concept of these threads is going to be very useful for the whole system. So let us begin with we'll try to understand what actually a thread is. So thread, as we say in very technical language, we can say it is a thread of execution or thread of control. Basically, your thread is actually a single sequential flow of execution of task of a process. So for example, you have various tasks within a particular process, and one particular task and its flow of execution, the single flow of execution, is a thread. Your operating system has a separate way of executing the threads, and there can be more than one threads inside a process. So basically, your threads is often referred to as a lightweight process. Each thread which is available in the same process, which is inside the same process, is going to make use of a separate program counter. So each thread is having its own separate program counter and a stack of activation records and control blocks. So your threads are having separate stack of AR, which is activation records, control blocks, and as well as program counters, which is going to be very different from the other threads. So each threads, even within the same process, are going to make use of these structures separately. So basically, what I'm trying to understand here, what I'm trying to make you understand here is, thread is having, all the threads are having separate program counters, separate stack of activation records, and separate control blocks, even if they are available within the same process. So now this thread is actually entity in execution, you can say. Then coming to the components of thread, what all can be inside the thread. So one, there is going to be a thread ID, which is kind of an identification, or which is a kind of you can say a number used to identify the thread. Then we have a register set corresponding to each and every thread, which represents the status of the processor, that what is the exact data available within those registers, processor registers. So one register set has to be there. Then in the next course of action, we will be seeing that threads can be a user level thread or a kernel level thread. So if it is a user level thread, a user stack is going to be there, which is employed when the thread is running in user mode. And if the thread is a kernel level thread, then there is a kernel stack which is employed when the thread is running in the kernel mode. So whether within the components of threads, whether it is going to be kernel stack or it is going to be the user stack, that depends on what kind of thread is actually under execution. Apart from that, it is also having a private storage area used by various runtime libraries and dynamic link. Apart from that, it is having the libraries and register set we have already mentioned. So in order to recap, it is having one thread ID which is there to uniquely identify the thread. Then there is a register set which is going to represent the state of the processor. Then either a user stack if the thread is in the user mode, or a kernel stack if the thread is of type kernel thread. Then a private storage area which is used by various runtime libraries and dynamic links, so and other libraries like DLLs. Now the question comes up, we have a process and then we are talking about various or multiple threads within those within a particular process. So what is the requirement of, kind of, I can say, division of process into threads, or what is the requirements of this concept of threading? So in order to understand the requirement, let's see that let us take an example that we are having, let's say, a browser which is working, and then you have multiple tabs. These multiple tabs can be different threads. So if you can recall the previous systems in which there were no kind of provision of having these multiple tabs, if you want to have one more kind of browsing session, you need to open the another browser window. So if you are opening the another browser, separate browser instance or separate browser window, that will be considered as a separate process. But if within the same window you are opening multiple tabs, then these multiple tabs are nothing but different threads. So another example of these threads could be one very good scenario which we use a lot is MS Word. So for example, one thread is there to format the text. For example, I need to increase the font or decrease the font, or maybe any other kind of formatting I am talking about. So there is one thread which is executing that particular formatting. Another thread could be there for checking the spelling thing. So there are multiple threads, and the process here is of MS Word. So MS Word process, or the instance of MS Word process, is using multiple threads for its different activities which are part of that particular process. So with these two examples, one is of browser having multiple tabs and another one of MS Word having these threads to format the text, and another thread for spelling checking. One intuitive idea here is we can achieve parallelism by dividing a process into multiple threads. If there is a single process and we are going to open another process for the next instance, it is a better idea to have multiple process, as in case of multiple threads, as in case of browsers I told you. So one window of a browser with multiple tabs is one process with different threads, and another browser window opened separately is another process. So here we are going to achieve the parallelism. That means the activities are going in parallel by dividing a process into multiple threads. Now what is the advantage of not opening a particular or not instantiating another instance of the process, rather than going rather one wants to go through the process of multi-threading? So why do we need this? First of all, this is a very kind of proven thing that it takes far less time to create a new thread in the existing process than to create a new process. Now please imagine the situation that you are opening another browser window or you are opening another tab. So for a computer or for a system, it is a far more less expensive, far more less complicated, far more less time consuming process to create a new thread within an existing process, rather than creating a new process altogether. On top of it, there are other advantages also, that threads can share the common data. They do not need to use interprocess communication. Interprocess communication and its complexities and its advantages versus disadvantages we have already covered in the previous lectures under the topic of IPC. So threads can share the common data. They don't need to use interprocess communication. Is not required for them to share the data. Then it is not only the creation of threads which is simpler. Context switching is also faster when working with threads, and we can kind of very much visualize it, or we can say we can feel it, we can see it practically, that switching between two different tabs within the browser is faster, it's easier, rather than jumping from one particular window to another particular window. That means I am talking about different instances of browser. So obviously context switching is more faster when we are working with threads, and also it is going to take less time to terminate a thread than a process. So what ease we are going to have as compared to the process. So thread being a lightweight process, it is going to share the common data without the nuances of interprocess communication. Then context switching is also faster, creation is also faster, and also termination. So the whole life cycle of a thread is going to be very less complicated as compared to the process. So threading or the concept of multi-threading is a preferred one when we are talking about the multi-tasking thing or multi-processing thing. So if the multi-threading is an option given as compared to multi-processing, multi-threading is the choice. And here you can see on the screen that there are two we can say portions of the figure. One portion or one part is giving you the feel of single threaded process. Another one is multi-threaded process. So single threaded process is having its code, the data, its files, its register and a stack, and within the execution space only one thread is getting executed. While if you can witness this multi-thread process, so it is having code, data and files, while registers and stack of all the three threads which are shown in the figure are separate. So here you have registers and stack for thread 1, then the separate registers and stack for thread 2, and the separate registers and stack for thread 3 as well. And this is what I also told in the when I was explaining the components of thread, that registers and stacks are having, each and every thread is having its own separate registers and stacks also. Apart from this, if we try to understand more the concept of this process versus thread into detail, we can see that threads are the execution units within the same process. They are running in the shared memory space, as you can see here in the figure. That memory space, which is the white area I can say here, is being shared between all the three threads in case of a multi-threaded process. In case of a single threaded process, only one thread is there, which is kind of I can say which is exploiting the whole memory space. So threads within the same process run in a shared memory space, while if we are talking about separate processes, they are going to have separate memory spaces. But even if a memory space is shared between the threads, a thread has its own program counter, which is PC, and we have already seen the usage of this program counter. Then it is having its own register set and also the stack space. Now this stack space could be the user stack space or the kernel stack space. That depends upon what kind of thread we are talking about, whether it is the user level thread or it's a kernel level thread. Then one thing which is very important here is, now it could be kind of taken as an advantage, also it can be taken as a disadvantage, is that threads are not independent of one another while the processes are. Processes are independent of one another. They are having separate memory space, separate data thing, everything is separate between the processes, while when there are multiple threads within a process, they are not independent of one another. They have the memory space as the shared thing, and without interprocess communication nuances, they can talk to each other, they can share data within one another. Then threads share with other threads their code section, data section and operating system resources like open files and signals and all those kinds of things. So there is also sharing between the threads, that what are they going to share. One thing which is separate is your program counter, register set and stack space is separate for all the threads, while the entities or the items which threads are going to share is the code section which they are going to share. Then we have the data section. Data section is also being shared, and the operating system resources like some open files and signals. And this you can witness within this figure also. If you can see, the code, data and files are common to all the threads. I am talking about the multi-threaded process. So the code, data and files are actually common between all the threads, as you can see, while the register and stack section is separate for thread 1, register and stack section is separate for thread 2, and the register and stack section is separate for the thread 3 or the third thread as indicated in the figure, while the code, data and files are actually shared. So these are some shared as well as kind of separate entities which threads are going to have. Now if we talk about what are the advantages, so now till this point we have understood what actually a thread is and how a single thread process is going to work, and how a multi thread process is going to work, what are they going to share, what are they going to have as their own separate items, and what is the difference between threads and process. Now if a multi-threading or if the multi-threading is being preferred over the multi-processing, wherever it can be preferred, it is always preferred. Now what are the advantages of threads over the process? So let us try to explain those advantages. The first one is the responsiveness. So if process is divided into multiple threads, and let's say we say that one thread is going to complete its execution, then the output can be immediately returned. So for example, let us consider the example of MS Word. So within that MS Word, one thread is doing the task of formatting, another thread is doing the task of a spelling check, and when the spelling check is complete, it is immediately reported to the user that so and so spelling, whatever the statistics, whether that you found any spelling mistakes or not found, whatever. Then 1 unit of execution we can say is getting completed. Now coming to it overall we can say it increases the responsiveness of the whole task. Apart from that, we can say there is a faster context switch between threads as compared to the process. So context switch time between threads is very low as compared to the process context switch. Process context switch is going to take more time, as well as it needs more overhead from the CPU. So faster context switch is also there when we talk about the advantages of threads over processes. Apart from that, if we see, there is effective utilization of multi-processor system. So in case of multiple threads in a single process, then multiple threads can be scheduled on multiple processors. So for example, we have multiple processors, or even we can say we have multi-core processor. That means having more than one cores within a processor. So multiple threads in a single process can be scheduled on the multiple processes, and this is obviously this is kind of achieving more parallel activities, or more activities which are going in parallel simultaneously, and obviously parallelism is something which is going to make your process execution faster. Apart from that, we have also seen that except the stack and registers, the resources like code, data and files can be shared among all the threads within a process. So here is a concept of resource sharing also, which comes when we talk about multi-threading process, or the or the task of multi-threading, or the concept of multi-threading. So resources like code, data and files are shared, while stack and registers cannot be shared among the threads. This is something which is actually a point which is worth noting. Each thread is having its own stack and registers. Then apart from that, we have other advantages also, that let's say we have communication. So communication between multiple threads is obviously easier, as we have seen that they share common address space. Without nuances of interprocess communication, communication can happen between the threads. While when we talk about the process, we have already seen in our topic of interprocess communication, which is IPC, that some specific communication techniques are to be followed when two processes wants to communicate with each other. That means kind of interrupts they need to generate, and so on and so forth. So while we are talking about some interprocess communication, some specific techniques or some specific ways are to be brought into the scenario, while it is a more much easier task when we talk about the communication between multiple threads, because they share a common address space. That's the reason. Then one major advantage of threads versus processes is we have the throughput, which is the enhanced one. So that means if a process is divided into multiple threads and each thread is functioning one job or one unit of execution, then we can say the number of jobs completed per unit time is going to be increased, because parallelly all the threads are working, and thus obviously this is increasing the throughput of the system. So we can say that we are going to have enhanced throughput of the system if we are going with multi-threading as compared to the multi-processing thing. Now let us try to understand this whole scenario of threads versus processes as well as its advantages with the help of a particular example. Let's say we have a web server which is going to accept the client request for various web pages, and these web pages may have text, images, sounds and videos and so on and so forth. So multiple kinds of requests are coming from various sites, we can say, and the web server is going to accept and process all those serve all those requests. So a web server which is very busy, it is having thousands of or maybe more clients which are concurrently accessing it. So if a web server run as a traditional single thread process, it would be able to service only one client at a time, and with so much demand, increased demand nowadays, one client at a time for a particular server is going to be disaster in terms of throughput. And because of this, a client might have to wait for a very long time for its request to be serviced, which is not acceptable, at least nowadays in the industry. So one solution here is to have the server run as a single process that is going to accept the request, and when the server receives a request, it creates a separate process to service that particular request. So this is kind of one at a time thing which is going on, and this method of process creation was very common before the concept of threads or before the concept of multi-threading. But please try to understand, this process is going to take much more time than a thread in its creation, in its context switch as well as in termination, and this we have already seen earlier. So this is going to be take much more longer time though. So this process creation is time consuming as well as the resource intensive. And also if the new process will perform the same task as the existing process, then why this overhead has to be incurred? So isn't it a good idea to have more efficient mechanism for that? And that more efficient mechanism is nothing but a process with multiple threads rather than multiple processes. So if the web server process is multi-threaded, the server will create a separate thread that listens for a particular client request, and when the request is made, rather than creating another process, the server is going to create a new thread in order to service a particular request or in order to service a particular client, and then it resume the listening for the additional request. So here this you can understand this with the help of a figure. So for example, a client request is coming, the server is going to create a new thread to service that request, and it is going to resume listening for another request. In this lecture we have seen threads versus processes in detail and all the nuances of thread. Here is a list of references which is being used for preparation of the lecture. Thank you.